XI says Grok 5 is planned for Q1 2026 after delays from earlier targets. Online commentary has speculated about AGI-level capability, but public evidence so far supports only that XAI is aiming for a stronger frontier model, not a verified AGI system. Meanwhile, on the security side, SecureClaw has emerged as an open-source security plugin and skill designed specifically to audit and harden OpenClaw agent deployments. These developments represent two parallel tracks in AI progress. One is about raw capability escalation. The other is about governance and control. In this video, we'll break down what Grok 5 is actually expected to offer, what AGI level really means in technical terms, and what SecureClaw is building on the security side of AI deployment. Grok is developed by XAI, Elon Musk's AI research company. The current production model is Grok 4.1, which is integrated directly into the X platform, where subscribers can access it as a chat interface. Grok is positioned as a frontier reasoning model, meaning it's designed to handle complex reasoning tasks, coding problems, mathematical reasoning, and long context document analysis. Grok 5 is planned as an update over Grok 4.1, but it hasn't been released yet. XAI hasn't published full public specs or benchmark scorecards for Grok 5. What is confirmed from prior Grok releases is that XAI has shipped models with real-time search integration and tool use in the Grok 4 line. It's reasonable to expect Grok 5 will continue in that direction, but specific Grok 5 technical details remain unverified until XAI publishes them. Based on XAI's approach with Grok 4 and industry patterns, Grok 5 will likely include several capabilities. Real-time data integration. Grok models have historically maintained access to real-time information through X's data feed, a capability that differentiates them from models with static, training data cutoff dates. Tool usage. Grok 4 supports interfacing with external tools and APIs. Grok 5 is expected to maintain and expand this capability. Expanded reasoning. XAI has signaled that Grok 5 will show improvements in multi-step logic problems and abstract reasoning tasks compared to Grok 4.1. Coding capability. XAI has publicly discussed prioritizing coding performance in frontier models, so Grok 5 is expected to maintain strong code generation and debugging ability. These are reasonable expectations based on XAI's stated product direction, but they are not confirmed specifications for Grok 5. When Grok 5 launches, XAI will need to publish technical details and benchmarks to verify these expectations. Here's where we need to be precise. For Grok 5 specifically, public benchmark scorecards and third-party evaluations aren't available yet. The model hasn't been publicly released, so independent researchers can't test it on standardized benchmarks like MMLU, GSM-8K, or HumanEval. For Grok 4.1, XAI has shared some internal testing results. The company reports that Grok 4.1 performs competitively with frontier models in reasoning and coding tasks. However, Grok 4.1 results have not been comprehensively submitted to public benchmark leaderboards like OpenLLM Leaderboard or HELM, where they could be independently verified and compared side by side with other models. When Grok 5 launches, the evaluation will follow a similar pattern. XAI will likely share internal benchmark results. The question is whether those results will be independently verified. If XAI submits Grok 5 to third-party benchmark suites, the community will be able to see exact numeric comparisons. If not, we'll be relying on XAI's internal testing claims. This is an important distinction. Company internal benchmarks are useful, but they're not equivalent to independent verification. A frontier model is best understood through both internal testing data and third-party evaluations. Without the latter, claims remain unverified. This is where we need to be extremely clear about definitions and evidence. Some online commentary uses AGI loosely to describe advanced frontier models, but the term requires a precise definition. Operationally, AGI would require several specific capabilities. Cross-domain general reasoning, the ability to understand and solve problems across widely different domains, physics, history, law, art, engineering, without retraining. Autonomous learning, the ability to learn and improve from new information and experiences after deployment without human intervention. Persistent long-term memory, the ability to retain and recall information across sessions and build knowledge over time. Goal-directed behavior, the ability to set its own goals and work toward them independently. Self-improvement, the ability to identify its own limitations and iteratively upgrade its own capabilities. Does Grok 5 meet this definition? Let's go through each criterion clearly. Does it learn autonomously after deployment? No. Grok 5 will be a frozen model trained on static data. It will not update itself based on user interactions. Does it self-improve independently? No. Any improvements to Grok 5 will require XAI engineers to retrain the model. Does it demonstrate persistent goals that it pursues independently? Number. Grok 5 will respond to user queries but will not autonomously decide what problems to work on. Is it still fundamentally a large language model trained on static data with weights that don't change after training? Yes. Here's the critical point. Grok 5 is likely a significant step forward forward in reasoning capability. It may excel at complex multi-step problems, abstract reasoning, and long context analysis. That makes it a frontier model, the best in its class in some dimensions. But frontier model capability is fundamentally different from AGI. A frontier model is the best large language model available. AGI would be a system that learns, adapts, improves, and pursues goals independently without retraining. The verified evidence does not support classifying Grok 5 as AGI or approaching AGI-level capability. It supports classifying it as a frontier reasoning model in development. Let's translate what a frontier reasoning model actually means in practice, beyond the marketing language. For developer productivity, Grok's improvements in coding suggest it's a valuable tool for software engineers. More accurate code generation means fewer iterations to get working code. Better debugging suggestions reduce time spent finding errors. This translates to measurable time savings on routine coding tasks. However, it doesn't mean developers can sit back while Grok writes entire systems independently. Complex architectural decisions still require human judgment. For mathematical and scientific reasoning, improvements in reasoning capability mean Grok 5 can handle multi-step proofs, numerical problem solving, and scientific reasoning more reliably. This matters for researchers, engineers, and students working through quantitative problems. But it doesn't mean it can autonomously design new scientific theories or conduct independent research. For long context document analysis, if Grok 5 expands its context window, it can process longer documents, full research papers, technical specifications, or lengthy code bases, and maintain reasoning coherence throughout. This is a practical upgrade for knowledge work. For agent-style workflows, where multiple tools are chained together to accomplish complex tasks, improved reasoning means Grok 5 can plan multi-step sequences more reliably, but it still requires human oversight and structured task design. The key distinction: strong reasoning capability is incredibly valuable. It does not equal general intelligence or autonomy. Grok 5 is a tool that amplifies human reasoning. It is not an independent agent with goals and self-improvement. While XAI is building more capable models, a parallel initiative is gaining traction on the security side: SecureClaw and OpenClaw. OpenClaw is an open-source framework for building and deploying AI agent applications. It's designed as a modular system that allows developers to construct agents that can reason, plan, and use tools. The framework emphasizes transparency and control, making it suitable for applications where auditability matters. SecureClaw is an open-source security plugin and skill developed by Adversa AI, specifically designed to audit and harden OpenClaw agent deployments. It's not a separate product. It's a security layer built for OpenClaw. SecureClaw focuses on three key areas: misconfiguration checks that identify common security mistakes in agent setup, hardening, guidance that recommends security best practices, and runtime guardrails that enforce security constraints during agent execution. Additionally, there are commercial offerings branded as Secure OpenClaw hosted deployments, which provide containerized, pre-hardened versions of OpenClaw with enterprise support. These are hosted services rather than a single standardized framework. Different providers may implement them differently. The core principle underlying both OpenClaw and SecureClaw: as AI agents become more capable and autonomous, the need for robust security, access control, and governance increases proportionally. Let's break down the concrete technical components. SecureClaw provides 55 automated audit and hardening checks mapped to the OWASP Top 10 for agentic security. These checks identify common vulnerabilities in agent deployments: misconfigured permissions, unvalidated tool access, insecure logging practices, and other configuration errors. The checks are automated, meaning they can be run regularly as part of a continuous security pipeline. OpenClaw's core architecture includes access control systems that allow fine-grained permission management. Administrators can define which users can access which agents, under what conditions, and with what rate limits. The framework also includes audit logging that records interactions with agents, creating a complete record for compliance and security investigation. On encryption and data security, E2EE is supported in specific channels. For example, matrix encryption is documented for certain deployment modes. TLS is recommended for gateway access. However, security ultimately depends on how the system is configured. No default setup is universally secure across all deployment scenarios. OpenClaw's documentation explicitly discusses specific security risks and mitigations. For instance, agent logs and transcripts can leak sensitive information if not properly secured. The docs recommend redaction policies and secure log storage. Secrets and API keys can be exposed if permission models aren't carefully designed. File permissions and agent working directories need to be restrictive. These aren't vulnerabilities in the framework. They're configuration decisions that administrators must make carefully. SecureClaw automates many of these decisions, providing templates and checks that enforce secure defaults, but the underlying principle is that security in OpenClaw deployments requires active configuration and ongoing audit. These two developments, Grok 5 and SecureClaw/OpenClaw, represent parallel escalations in AI infrastructure. Grok 5 represents capability escalation. If it delivers on the expected improvements in reasoning, coding, and long context analysis, it will be a stronger frontier model. That creates value for users and developers who need advanced reasoning capability. SecureClaw and OpenClaw represent governance and security escalation. As agent systems become more capable and autonomous, they become more powerful tools. Powerful tools need control mechanisms. Organizations need to deploy agent systems while maintaining security, auditability, and control. SecureClaw is the technical response to that requirement, a security layer that hardens agent deployments. The connection is logical. As models and agent systems get stronger, the stakes of deploying them increase. Stronger reasoning capability could be misused. Autonomous agents that can use tools need robust permission models and audit trails. Better coding ability could be used maliciously if access isn't controlled. None of these outcomes is inevitable. They depend on how systems are deployed and what safeguards are in place. SecureClaw provides those safeguards. This is not dramatic framing, it's pragmatic infrastructure development. AI progress now spans two parallel dimensions: capability escalation and security escalation. Building stronger models is only half the equation. Deploying them safely and with proper control is the other half. Grok 5 is planned for release in Q1 2026. When it launches, xAI will need to publish technical details and benchmarks for the community to verify its capabilities. There is no verified evidence it qualifies as AGI or approaches AGI-level general intelligence. It is a frontier reasoning model in development, likely stronger than Grok 4.1, but still fundamentally a large language model with static training data, not a system that learns, improves, or pursues goals independently. SecureClaw reflects a growing infrastructure reality. As AI agents become more autonomous and capable, organizations need more sophisticated security and control mechanisms. The framework provides concrete tools for hardening agent deployments, auditing behavior, and enforcing access control. AI progress now spans two tracks simultaneously. One is about capability advancement, better reasoning, better coding, better performance. The other is about security and governance escalation. Robust frameworks for safe deployment, control, and auditability. Both matter. Both are accelerating.